So welcome back, everybody. This is 1.3.1. Again, part two. So I noticed one of the mistakes I made at the last part of the video was that I said the final answer was 16 times 10 to the fifth. Now we have to be careful because if we're using scientific notation, the first number right here has to be between 1 and 10. So that's very important. So in this case, all I have to do is just add a decimal, and my answer would be 1.6 times 10 to the 6th power, because I added that decimal right there. So my mistake. Just make sure you guys correct your notes right there. And then for the next part, let's look at 166. Some of the equivalent expressions below are correct and some are not. Expand the expressions and use giant ones to justify whether or not each pair of expressions is equivalent. If they're not equivalent, identify the mistake and correctly simplify the expression on the left side of the equal sign. So part A, we want to see if that's correct. H to the 3rd power times h to the 4th power times k, and that's equal to h to the 12 times k. So if we expand this right here, we'll notice that's h times h times h, and this one would be h times h times h times h times k. So here we have a total of 7 h's, so h to the 7th times k. So these two are not equivalent right there, and pretty much what they did was that they multiplied the exponents to get 12 instead of adding them. All right. Part B, so 39p to the 4th times q to the 5th over 3p squared times q squared. So again, make sure you guys write out those giant ones. So the first one's going to be 39 divided by 3 times p squared over p squared times p to the 2nd power over 1 times q to the 5th over q to the, it'll be q to the 2nd over q to the 2nd times q to the 3rd over 1. Let me write that so it looks a little bit nicer. So q to the 3rd over 1. So these are our giant ones, like always, right there. There's 1. There's another one. 39 divided by 3 is 13. And that leaves p squared. That's another giant one right there, times q to the 3rd power. So that one seems to be true. Part C. So same thing. So the base is 9. 9 to the 2nd power times 5 to the 3rd power divided by 9 to the 3rd times 5 to the 2nd power. So write out your giant one. So that would be 9 to the 2nd over 9 to the 2nd times 1 over 9 to the 1st. Now, if you notice, that I'm supposed to have 3 at the bottom. So 2 plus 1 still gives me 3 times 5 to the 2nd over 5 to the 2nd times 5 to the 1st, right? So the top one also adds, the exponents add up to 3. So here again, if you simplify, you'll notice that these two are your giant ones, and you're left with 5 over 9. So that was correct as well. On D, so here, does this seem to be true? Is 3 to the 5th power times 3 to the 2nd power equal to 9 to the 9th power? So here, this is one of the common mistakes. You're not supposed to multiply. If there are numbers right there, don't multiply the numbers. Just rewrite it the same. And then if you notice, they kind of messed up also with the exponents. So that's 3 plus 2 is actually 7. All right. So the next one. So we have scientific notation, 9.8 times 10 to the 6 over 0.5 times 10 to the 6th power. So again, these are our giant ones right there. So this one's almost true, but it's not in scientific notation. Our result has to be in scientific notation. So 18 would be the same as 1.8 times 10 to the 1st. On the next one, if you notice, what do we have? We have w to the second power over w to the fifth power. That equals to w to the third power. So w squared over w squared times 1 over w to the third power. So this is our giant 1 right there. And we're left with 1 over w to the third power. So this one's also not true. On G, we have, again, it's in scientific notation. So we're going to have 7.0 times 10 to the third times 7.0 times 10 to the third divided by 3.5 times 10 to the second power. You want to make sure that those two are equal. So here, if you notice, let's see what happens. So 7 times 7 is actually 49 times 10 to the sixth power over 3.5 times 10 to the second power. And if we do divide this, 3.5 actually goes into 49 a total of 14 times. And then these two, that would be 10 to the second over 10 to the second times 10 to the fourth. So that would be times 10 to the fourth. And again, like I did the mistake last time, make sure you rewrite it in scientific notation. 14 is not between 1 and 10. So this is going to be at a decimal in the middle right there. So it's going to be 1.4 times 10 to the fifth. And now these two are the same. For the next one, so we want to simplify 5 over 10, and then times g to the fifth over g to the fifth times g to the 45. So 5 over 10, that's an equivalent equation, an expression of 1/2, so 1 over 2. And then that's our giant 1, and then g to the 45. So this seems to be true as well. All right. And then what do you think about I? Is that true or false? So for this one, expand it 4 times. So x squared times x squared times x squared times x squared. And then that's going to be a total of 8 x's. So that gives us x to the 8th. So therefore, this one is also false, not equal to x to the 6th.